Good day. Measurement's very important in the world of science. It allows something called repeatability to occur. So we want to do careful jobs of measuring things. And here we have a graduate cylinder worksheet, which is actually notes. You will not hand this in. So it says determine the value for the minor grids on each of these cylinders. So it wants to know the gap. Well, how big is that gap? Well, it says from here 0 to 10, we had 10 divisions. So in this case, each gap would be 1 milliliter. In this case, we go from 0 to 10, and we see there are 5 divisions. 10 divided by 5, that means we'd write down 2 milliliters. Every time we go up a line, we're adding 2 milliliters. Now for C, we go up 1 milliliter, but there were 5 divisions. So 1 divided by 5 is 0.2, so it means 0.2 milliliters is we rewrite for C. 0.2 milliliters every time we go up by 1 there. In this case, we went from 0 to 1, and there were 2 divisions. 1 divided by 2, so each division is 0.5 milliliters. Now they've done an example here. They're showing the meniscus, the creeping up on the sides, in this case of water up the graduate cylinder. And we always measure to the bottom of the curve, the bottom of the meniscus. Well, we look at our divisions and we see, oh, here's 10, here's 20, 10 divisions, so each division is 1 milliliter. We know with certainty it's between 12 and 13 milliliters. And then we have to estimate. So they've written down 12.4 milliliters. Someone might write down 12.3 milliliters, and that would be okay. What this is saying is we estimate the last digit of any measurement. If we're doing it properly, we're estimating. And that means there's a little bit of latitude. We're going to try some here. Right now, we can see there's 20, there's 25 and 30. We know we're between 25 and 26. So I could write down 25.1 milliliters, or I might write down 25.2 milliliters. Either of those is acceptable. Here, I go, oh, there's 35, 36, 37. I know for sure it's between 36 and 37, so I'd write 36. Now I estimate how far between. So I might say something like 36.6 milliliters. You might look at that and say 36.7 milliliters, because we're estimating that last digit. That is fine. When we look at this one, same idea. And we go, okay, here's 5, 6. Each division is 0.1 milliliters. So you go 1, 2, 3, 4. We can see it's between 5.4 and 5.5. So I might write down something like 5.45 milliliters for this one. I know for sure it's between 5.4 and 5.5. The question is, how far between? And on this one, I can see I'm between the 15, or let's see, 1, 2, if I can get my eyes working well. So I can see I'm between 14 and 15. And so I might say something along the lines of 14.8 milliliters. You might say 14.7, 14.9. All equally correct in the sense we're estimating the last digit. Here is something we don't do as much. It's saying 49.21. So we go 49, there's 0.1, 0.2. And we put a line across right around here and curve it up at the ends. So you can try those out, see if you can reverse the process. Instead of giving the line going to number, you're given the number and you go to the line. This is something that's fairly important in grade 8. It becomes much more important in your senior science courses when you're doing very precise measurements.